In example 4, what we're going to do is we are going to go through a problem where what some of you will notice is that you're not going to want to use completing the square here as one of your methods of choice. You still need to learn how to do it and you still need to practice it, but if you don't like fractions, then there's a chance that you would choose factoring if this was factorable or quadratic formula if you didn't want it, if it wasn't factorable. Could you use square roots to find this? No, because there's the bx, right? But you can complete the square. It's just that you're going to have a fraction with it. So we're going to go through the example. You need to practice a couple with the fractions, but then once it's a method of your choice, you just wouldn't choose completing the square if you don't like to have the fractions there, okay? So do we have an a that we need to divide out here? No, so we're going to go right to finding our new c. How do we do that? Divide what by 2? Divide b by 2 and square it. So 9 over 2 squared equals what? 81 over 4. Now you rewrite your equation with your new c. What do I have to remember to do here? Both sides. Okay, both sides. So x squared plus 9x plus 81 over 4 equals, I'm going to go ahead and put 136 over 1 right now. Why would I do that? Because now I'm going to be able to find a common denominator and add these together, right? So I have a little bit of an extra step on the right when I have a fraction. On the left, I'm going to follow the same rules I've always followed here. So this is a trinomial square. We already know it's a trinomial square because we set it up that way, right? That was the point in setting it up like this. So how many sets of parentheses are we going to have on the left here? One set of parentheses, just like last night, squared. What's the square root of x squared? So that's your first term. Sign from your middle term. Positive. And then, look, you already have your square root of 81 over 4 right there before you added it to both sides, don't you? So you already know the square root of 81 over 4. It's 9 over 2. But you needed that squared to be able to add it to this side and have it here so that you could take the square root of it. So now you have 9 over 2. X plus 9 over 2 squared equals, now we have a little bit more work to do over here, don't we? How are you going to get a common denominator between these? Multiply the numerator and the denominator of the 136 over 1 by 4. When we multiply 136 by 4, we get 544. So now we have 544 over 4 plus 81 over 4. Does everyone see how we did that? Now what are we going to do? Add what? Add your numerators. 544 plus 81 is 625 over 4. Does everyone see that? Does anyone remember 625 being a perfect square? Can anyone think of if it is? Put it in your calculator and try it out and see. Try 625 as a perfect square. What is it? 25, isn't it? As you get better at recognizing these as perfect squares, what I notice here is I have a perfect square and I have a perfect square, don't I? So this is going to be pretty easy to simplify without my calculator at the beginning here when I go to take my square roots. So just be aware of that as we bring this down. So now we have 625 over 4 here. Oh, sorry. I don't know why I did that. I said 625 and then I wrote 652. Sorry. There you go. As I do this, why did I leave space here? Because I'm going to end up putting a plus or minus when I do what to get rid of that squared? Now we're to that step last night. How do we get rid of squared? square root of both sides, and when we take the square root, what do we do to the solution side? The plus or the minus. So you get used to leaving that space there so you don't forget about it. So now if I take the square root of this side and the square root of this side, plus or minus here. Looks pretty complex, doesn't it?
Yes.
But it really is. I mean, so far, has anything been something you can't do yet? No, just looks scary. What happens to our square root and our square?
Cancel.
These cancel, and I end up just bringing down x plus 9 over 2. Does everyone see that? Equals plus or minus. Now we already decided these were perfect squares. Two ways you can get to this. You can divide 625 by 4 and then take the square root of that number, and you'll get the answer. Or you can just look at this and say, you know what? I'm going to keep these in fraction form right now. I know that's a perfect square, because the square root of 625, you all said is 5, right? Or 25, sorry. And then the square root of 4 is 2. So I can say it's plus or minus 25 over 2. Really nice thing here. Do you all notice that when you move 9/2 over, you already have a common denominator this time, don't you? You won't always have that. And some of you are going to end up using calculators and you're going to get a decimal here. If you use a decimal here, then eventually you're going to need to convert that to a decimal also to be able to combine them. Or you're going to need to convert this back to a fraction to be able to combine them. So that's just where you have to go with your personal preference. But if you're talking about a test where you can't use a calculator, then you obviously want to make sure these stay in fraction form. Don't try to convert them to decimal form. Okay, so now in order to get our two solutions, we're going to set up our two equations by subtracting 9/2 from 25/2 and negative 25/2, right? So set up your two equations. X equals a positive 25 over 2, minus 9 over 2, and x equals a negative 25 over 2 minus 9 over 2. You've got to be very careful with your integer rules here. It's not worth missing these over something like that. So we already have a common denominator. What's 25 minus 9? 16 over 2, which equals what? So positive 8 is one of our solutions. Here we have a negative and a negative, so what are we going to have for x? Negative what? 34 over 2, which equals what? Negative 17. So your solutions here are x equals 8 and negative 17. For students who were not in class on Friday, this is the worksheet if you would like to write the problems down and solve them on your own paper. Everyone is going to do number 1, number 2, five, 1, 2, and 5. Now go to the next page. And 9. And 10. How do you think you could check your solutions to those 5 problems? A different way. What's the way that you know for sure will work? The quadratic formula. So what you're going to do is you're going to try it by completing the square. Once you get your answers, if you want, you can try factoring. Or you just go right to quadratic formula, and you should get those same answers both times for those. Get started.